So hello everyone again. So I am Shripan Mandal, currently working as a research scholar at IIT BHU Varanasi, and I am taking this course, and this is the seventh week for this course as a deliverable towards my PMRF scheme, and this is the seventh class, and in the last class what we are studying is solving differential equations using Euler, modified Euler, improved Euler as well as RK4 methods, and we see how the accuracy and precision depends on the step size what we are taking for the independent variables, and how it is changing from method to method. Okay, so today what we are going to do, so as you can see from previous lecture, in the last problem in the previous lecture we calculated, or we estimated, or we solved a second order differential equation, in which we do that the second order differential equation can be written as a coupled two coupled first order differential equation, and then we solved it by RK4 method. Okay, but that is for just a one particle. But if we have a series of particles which are interacting with each other by some forces within them, then how to solve for each of the particles in that particular ensemble of the particles. Okay, so that is the first question in the assignment given in the week 7 in the previous year. So let's have a look at the question. Okay, so you see that suppose you have 50 particles in a circular ring of radius 5 placed on the xz plane. There is periodic boundary condition such that 50th particle has particle number 1 and 49 as its neighbors. Just a second. So okay, so what happens is you have so 50 particles. Okay, so if we try to draw what the question is suggesting, let's say you have this kind of a circular ring. Okay, and you have this kind of a particles. Let's say these are your particles, and in this way a total 50 particles are there. And what happens is, let's say this is the 50th particle, then what happened that for each particle it will have the nearest neighbors. Like if it is 2, let's say this is the second particle, then it will have the nearest neighbors in the form of 1 and 3. Okay, but whenever you have the 50th particle, or let's say 1th particle, then what happens that you cannot assign the nearest neighbors in the pattern given here, that you cannot assign that. Okay, I plus 1 and I minus 1 will be the nearest neighbor for the ith particle if I is 1 or 50, because in that case what will happen that you have to assign the periodic boundary condition that okay, for 1 we are going to take 50 and 2 as the periodic as its nearest neighbors, and for 50 we have to take, since there is no 51, then we have to take 1 as well as the 49 to be its nearest neighbors. Okay, so this has to be put in our mind while we're writing the algorithm for this particular question. Okay, so let's move on to this question. And the spring constant kappa equals to 1, and the mass of each particle is given as 1. So such that kappa by m, so whatever it is, that let's say you have the particles being the mass of m. Okay, so what the equations of motion of them, let's say for ith particle the equation of motion will be m d2y dt2, okay, equals to minus it will be plus. Okay, so let's say for this question, because the force is given as this, so you can write it as and since km is 1, then you can write it simply y I plus 1 plus y I minus 1 minus 2 y I. Okay, so this will be the equation of motion. And what you can do is say you are taking that dy, you can remember this if you see my last lecture. Just a second. Hello Shoumitro. Hello. Hello, am I audible? Hello Shoumitro.
Yes.
Am I audible?
Yes.
Okay, so I just started the recording because no one is coming. Okay, so you can follow because I have just started. So okay, so what we have is a question like this, that in the last class you can remember that we have just one particle, and we have the second order differential equation, and we are transforming the second order differential equation into two coupled first order differential equation, and then we are assigning that dx dt, let's say that dx dt to be v, and then what I have, that dvdt equals to some form of force, right? So that was the strategy to coupled two equations, and then we can solve that by RK4 method. So let's say here is some force which is depending upon x, but instead of one particle we have in this question let's say 50 particles. So you have 50 particles in a circular ring. So let's say you have xyz plane where this should be y.
So you
Yes,
do not share your screen.
It's not shared.
No.
Okay, just a second. Is it okay now?
Yes, it is okay.
Okay, just a second. Yeah, sure. Yeah. So yeah, so we have 50 particles. Okay, and the thing is we have to check for the periodic boundary conditions. Since this is a circle, let's say you have the 50th particle here, so you are starting from 1 and you are going to 50 in this way. So for 50th particle, the nearest neighbors will be the 49th and the 1, and in this way you cannot give the value of the nearest neighbors for the 50th particle, because I plus 1 for that will be 51, and 51 is not there. And similarly for 1 you cannot assign the I minus 1. So whenever we are trying to write the algorithm, we have to look for this, that we have to assign the nearest neighbors, and this forms in a different manner whenever we are trying to calculate the equation of motion for first or 50th particle. Okay, so here what will be the equations of motion? So first of all, let's say you have the equation of motion for d2 yi, let's say for ith particle, that will be d2 yi dt equals to this formula, right? So let's say y I plus 1 plus y I minus 1 minus 2 yi. Okay, so this will be my form, and then what I can do, we can transform it to two coupled first order equation. Let's say dy I dt, that is assigned as vi, the velocity of the ith particle, and then we can tell that this one is equals to dvi dt, right? So we have again two equations, but this time for a particular particle we have two equations and we have total 50 particles, and we have to calculate the equation of motion for all the particles as that as the iteration is going on. Iteration is with respect to time, and the initial conditions as follows, as that at t equals to 0, for the initial time velocity of all the particles should be 0. So this all the particles are static initially, and the displacement in the y directions, since they are in xz plane, then the direction of displacement will be y. And you see, except 1 and 26th particle, each one of them will not have any displacement initially, and the 1 at 26 particle will have a displacement of 0.8. And then you have to use RK4 method with dt, the time interval, to be 0.02. We have to find yi, that is the displacement of ith particle, for each of I as a function of time. The position of the fourth particle after 2000 iteration has to be calculated, and we have to check which one of the option is correct. Okay, so the question is understandable, right, Soumitra?
Yes.
Okay, so have you done this kind of a problem?
Yes, I have.
Okay, fine. So let's I think, okay, so let's move on to the code. I am not going to show in this way because let's move on to the other folders. Just a second. Yeah, so we have this code, right? First of all, that we assigned dt to be 0.02 and number of particles is 50. Then what we do, instead of taking x, v, f naught, each one of them to be just a single value, we have assigned them to be one dimensional arrays. And what I did, that I have given the initialization, that initially, let's say we have a loop which is running for each one of the particle, and initially I am taking that all of the values in the velocity as well as displacement arrays to be 0, and then I redefined the displacement for fast and 26 particle to be 0.8 as per the question. Then I am giving that, okay, number of iteration is reduced as niter, and that will be for our question 2000. So what I did, that I am giving the niter number of iterations, and in this case instead of one particle we have 50 particles, so we have to have a loop over the particles also. So let's say for the first iteration, what we have to do, we have to calculate all of the equation of motion for all of the particles. So in the first two cases, you see that if k is equals to 1, let's say you have 50 particles, okay, NOP is to be 50, and then if we have if we have to calculate the equation of motion for the first particle, what we need to do, is to calculate, just a second, what we need to do is to calculate the uh, take the first or the second or 50th particle under consideration for the force of interaction between them. And when we are considering the equation the equation of motion for 50th particle, we have to consider the 49th and 1th particle as the nearest neighbor for the 50th particle, and we have to calculate all these things as the RK4 method suggests. And then if uh, k is not equals to 1 and 50, then we have those particles within 1 or 50, right, from 2 to 49. And then for those cases we can calculate this way, because the RK4 method suggests us RK4 method suggests us that you have to calculate the y equals to 1 by 6, right, f naught plus 2f1 plus 2f2 plus f3 and plus y, right. So this way you are going to update the value of y. So here you see all of the things are repeated as the previous class. So how do you going to define f0, f1, f2, f3, that you can see from the previous lectures. Okay, so then from previous lectures, and then what you have to do is you have to assign those things like xk, vk, and you can write all of these things in a file. Okay, the file is named as rk4 coupled w7.dat. okay, so what we have in the question that we need to find out the value of displacement for the fourth particle at the end of 2000 iteration. So that will be printed in the command prompt. Okay, so if we go back to this one, so let's say we have the file name as rk4 couple.f. so what I can do is g4run, right, rk4 coupled.f. okay, so this will be ./a.out. so it will ask for the number of iterations. Since we are interested in 2000 iteration, then I am going to give it 2000, and that will give us the value of x4 at the end of 2000 iteration to be 3.66 into 10 to the power minus 2. Now if we look at the equations, the options, then we can find out what will be the correct answer. So here you see the correct answer will be, so you have 3.366 into 10 to the power minus 2. So this is not exactly the same, but the answer will be this one because the order is same, and it will be 0.0366 in as per our solution. But here this is given this, so this is the correct answer for this particular question. Okay, yeah. So if we move on to the next question, what will happen is the second question. So solve the differential equation y double prime minus f of y prime plus 10y equals to 10x using Gauss Seidal method, and with the boundary condition y equals to x equals to 0, y at x equals to 1 is 40 with dx to be 0.01, and convergence condition as 0.0001. So use double precision for all the real variables, and the boundary condition will be, so this will like this, that for x equals to 0 you have the value of y to be 0, right, and for x equals to 1 you have the value as y equals to 40, right, and dx is given as 0.01, convergence condition to be 0.0001. Okay, so these are the given values. So what you need to do is the value of y at x equals to 0.78, you need to find out that. Okay, so let's move on to the coding part. So here is the code for this. So I have defined that f underscore x to be 0, so that is the initial value of x, and the end value is 1. So then I have also defined the fy and end y, that is the initial value of y and the last value of y. Okay, and you see this term 1, term 2, term 3, term 4, these are those things which are taken, or which are the calculated which are multiplied with the different yeah. So let's move on to this question and try to understand how the things are going. Okay, so y double prime is given as y I plus 1 plus y I minus 1 minus 2 y I by h square minus, since this is y double prime, okay, so 5, there will be y, sorry, let's have a bracket, y I plus 1 minus y I minus 1, right, by 2h plus 10 yi equals to 10 xi. Okay, so if we have to calculate the value of yi, we can get those kind of a thing. So you need to write down yi as a function of y I plus 1 comma y I minus 1 and xi. Okay, so in this way you are going to find out those equations, or those values of dum and dum3, dum4, those things. So you see, in that case you are going to get these equations. Okay, and then you have to write number of grid points. Just a second. Yeah, so what we have is this one, right? So you have this way you can calculate, or you can write this equation in this format, and then you have to calculate yi equals to this one, okay, as a function of y I plus 1, y I minus 1 and xi, and therefore whatever the things are multiplied to each one of these terms, that will be given by this term 1, term 2, term 3, term 4. Okay, so in this way you can write the equation, and you can calculate the value of yi using the yi plus 1, I minus 1 and xy. So then you have to given the number of grid points. Sorry, this is not given by you, it will be generated, or it will be the output of the code as it will compiled. So the limit as per question is given by 0.0001, so 10 to the power minus 4, and then you have a open loop and the loop parameter to be LL, which will be 1, sorry, which will be 0, and the condition is set to be 0. So this condition is used for the meet of the limiting condition. So let's say and then you are opening a file by this name, and then you are assigning the first value of x parameter and sorry, x and y array as this, that fx is given by 0, and at 0 for for the 0 value of x you have y to be 0, right? And then the last for the last the x value will be given as 1, and for the last value of x the y is given to be 40 as per question. Okay, then we have a do loop running for I equals to 2 to NOP minus 1. Okay, so and in that case xi, that means ith element of x array, that will be assigned in this way, because dx is the increment of x, which will be in our case it is 0.01 as per the question. Okay, so from there on we can assign the yi value in this way. This is nothing but a slope, right? So whatever we have a value of y like y I minus y0, right, that will be equals to what? X I minus x0, and that is equals to what? That is equals to the slope, right? And this way you can write up that yi is going to be what? M xi minus x naught plus y naught, right? So in this way you can calculate the values of yi here. Okay, so this is essentially the thing. Okay, fine. And then m, this m is nothing but that int y minus fy by int x minus fx. Okay, and then what you are doing, that since x naught is 0, so you are taking this 0, and y naught is also 0, so you are taking this 0. So m is written as int x, the int, so okay, just you can see from here that int y minus fy by int x minus fx, this is essentially the m. Okay, so you are calculating y, and then you have opened a do loop which will not have any condition like I equals to something, rather it has some condition. Until the condition will be met, the loop will not exit. It will be continued to calculate the value of yi. Okay, so what happens, that initially LL is given a value of 0, then if condition equals to 1, then it will exit the loop. Okay, so that is the condition when the loop will completely exited. So y old is another array in which we are storing the value of y before updating the y. Okay, again I used the do loop which is running from 2 to NOP minus 1, that is the total number of array elements minus 1, and then yi is updated in this way, that yi is dump 1 into dump 2 into y old plus dump 3 plus, you see here it is using the older value of y, but in this it is using the value of the y which is already calculated in this particular iteration. So basically what happens, that whenever you are calculating the value of y for the ith element, till then the ith minus 1th element of y array is calculated. So whenever you are trying to calculate instead of Gauss Seidal method, you are using that particular method. Then you can see in that case you are using both y old I plus 1 and y old I minus 1 in that case. But whenever you are calculating Gauss Seidal method, you have used this y for this for that ini for that running iteration. Okay, so what will be the advantage? The advantage will be like you have the convergence that will be the faster than that case, right? So then it say that okay, each one of the things have been calculated and then condition is 1. So if condition is 1, then it will exit. Also what we did, that now let's test the convergence. So what is the convergence test? That the absolute of y volt minus yi, that means the change in the y value from one iteration to another iteration, that change whether it is greater than equals to limit. A limit is 0.0001. So then we are saying that okay, condition is 0, and until condition is 0 we have this loop calculating or updating the y value again and again, and when it is giving that condition is 1, then that means that this absolute difference between these two has to be less than equals to limit. Then the loop will exit. Okay, and then it will write that number of iteration required to achieve convergence to be LL, which since this is just adding one by one. Okay, and finally you can write the value of x and y in a file called this one. Okay, and then we have to end the program. So let us move to the code part. So here is the particular code for this, and I am going to show the terminal where I am going to write, compile the program already have written. The name is Gauss underscore Seidal. So Gauss Seidal dot f. Okay, so it is compiled. Now we have to check for the answer, and that will be, you see, number of grid points are 100, and number of iterations required to achieve convergence is 7161. So you have a 5 right here. So what you can do is you have to add another loop here. Let's say if, right, let's say here you are trying to add. So if xi equals to 0.78, right, then what I have to do is print star y, right? So this is the thing question is asking, and if. So now if we try to again calculate this, it will give you the answer. Just a second. So .78. Maybe something is wrong in this part. So however we can check this. Okay, so again I'm going to run it, it will generate a file. Let's say this file, and you can check for 0.78 it will be the value. This one, this will be 23.824, right? So just a second, I have to look another time for this code. That, let's say, if xi equals to 0.78 t0, then print star comma 1, right? And if, let's check whether it is working or not. If it is not working, you can see from the data file itself. No, it's not working for some reason. I am not understanding that at this moment. So let's say you can have a look for this. So you see, you have 0.78, and for this the value 23.824. so if we look for the values now, so that will be essentially 23.824. this will be the correct answer. Okay, so for this assignment I have just 2 questions to solve, and I have shown the solutions. So I am extremely sorry because today there is some electricity issue in our area. So in between class the Google Meet was stopped, as well as my camera was not showing my face. So nevertheless I have recorded this via offline recorder. So I will upload it in the YouTube. You can check my lecture from the YouTube, and hope it will be useful for all of you while you are trying to solve the assignments in this year. So thank you very much for no one is attending today, so okay, so that's it for today. Hope you will learn something about solving differential equation from this live session, or I may say from this video through YouTube. So thank you very much. Happy learning. See you again on next Sunday.